Welcome to my algebra class. We're on chapter 9 and we're doing a method that is not in the book. It's using determinants and matrices, and the method was discovered by a gentleman named Kramer, so it's called Kramer's rule. We're only going to use the numbers in front of the variables, so we're only going to use the 3, the -4, the 5, and the 9, and we're also going to use the constants, the number after the equal sign. Now this method, in order to use it, has to be in standard form, the equations, so you have to get them this way before you use it, just like we have to do it that way in order to add or subtract or multiply. So we're going to use a matrix. A matrix is just a row and columns of numbers, and we're going to use a 2 by 2 matrix, 2 rows, 2 columns. And we're going to put in the matrix, which is indicated by the bars, we're going to come up with 3 matrices. One comes from the coefficients in front of the variables. One comes from replacing one column with the constants, and the other one placing the other column of the variable we're finding with constants too. So let's start with the coefficient determinant. The coefficients, we put them in the order that they appear: 3, -4, 5, and 9. And when we find a determinant, it's like cross products. We take 3 times 9, this multiplication first, minus, then the other diagonal, 5 times -4. And that gives us our determinant value. So this would be 27 minus the -20, which is 27 plus 20, which gives us 47. Now we're going to find the x determinant. The x determinant, when we find that, we take, since we're looking for the x, we're going to substitute in that column, that matrix, that column, we're going to substitute the constants in there. So that matrix looks like this. It'd be 2, 1, and then the b and the e stay the same, -4, 9. And then we do our multiplication again. 2 times 9 minus 1 times -4. So that's 18 minus a -4, or 18 plus 4, which is 22. And then our y determinant, since we're looking for a y, we're going to keep the x column 3, 5, and we're going to put the constants 2, 1 in the y column. This is the x column, this is the y. So doing our multiplication, we get 3 times 1, 3 times 1, minus this diagonal, 5 times 2. So it gives us 3 minus 10, which is -7. So how do we find x and y? Well, x is the determinant of x, which was 22, over the determinant for d, which is the actual coefficient determinant right here. This is d, which is 47. And the value for y is to take the determinant of y, which is -7, and also put it over the determinant, the coefficient determinant, 47. Now here you see the value of using this method here, because we came up with some unusual fractions here. Not unusual, but hard ones to work with if we did a system. So this is the value of it. And when we do the problems, I'll show you that it does work either way. We'll get the correct answer. Okay, with that in mind, we'll do the evens, and hopefully you'll understand it a little bit better there. So we're on 433, and we're doing 1 through 14. Now, the book says to do it by a variety of methods. We're taking all of these and doing it in using determinants. So we first have to make sure that our systems are in standard form. That's ax plus by equals c. So x plus y equals 1, that's fine. And the 5x plus y equals negative 7 is correct. When you do number 1, neither one of them is in standard form, so you'll have to get them that way. All right, then we look at the, we'll make our determinant, our matrix for our coefficients. And we have 1, on the x column we have 1 and 5. We're looking at the numbers in front. In the y column we have 1 and 1. And then we do our multiplication. 1 times 1 is 1, minus 5 times 1, which is 1 minus 5, which equals negative 4. So that's D. Now to find the value of x, we have to do the matrix for x. Since we're looking for x, that's where we put the constants in. That's right here, 1, negative 7. We leave the y column alone, 1, 1. Doing our multiplication, 1 times 1 is 1. Minus 1 times negative 7, which is negative 7. So that gives us 1 plus 7, which is 8. And our determinant for y, since we're looking for y, we leave the x column 1, 5, and we put in the constants for the y column. This is the y column, 1, negative 7. Do the multiplication, 1 times negative 7 is negative 7, that way first, minus 5 times 1, which is 5, so that gives us negative 12. So x will equal 8 over negative 4, which is negative 2, and y will equal negative 12 over negative 4, which is 3. So our ordered pair should be negative 2, 3. And just, you don't have to write this down, but just watch for a minute. If I go back up here and subtract them, which right now looks a little bit easier, but if I was actually solving this problem, I probably would just subtract them. So I get negative 4x equals 8, divide by negative 4, x equals negative 2, which is what I have here. And then I would plug it in. And 2 plus y equals 1, subtract 2. And x equals, y equals, I'm sorry, x is negative 2. And then x, add 2 to both sides, and then y equals 3. So I got the same thing. The value of the determinants is when the results are fractions that are not easy to work with. Okay, we're going to continue doing this. Problem number 4. The system is a equals 3b and a minus 5b equals 16. So the second one's okay, the first one's not. So we got to get in standard form ax, so a's fine, bring over the 3b, so subtract it, equals 0. So if I take away 3b from this side, I have 0. And then I have a minus 5b equals 16. So the numbers in front are 1 and 1. That's my x column, negative 3 and negative 5, and my constants are 0, 16. So making my array for the determinant of the coefficients, I would have 1, 1, negative 3, negative 5. And then to find that value, cross multiply in a sense, negative 5 minus 1 times negative 3 is negative 3. So that's negative 5 plus 3, which gives me negative 2. So that's that value. Now let's find the determinant for the x value. So since I'm looking for x, I don't put 1, 1 down. I put the 0, the constants, 0, 16, and then I leave the y column alone. So 0 times negative 5 is 0, minus a negative 3 times 16 is negative 48. So that's 0 plus 48, which is 48. So that's my value for the D matrix, X matrix. Now D of Y, since I'm looking for Y, I leave the X column alone, and in the Y column I put in the constants 0, 16. Multiply 1 times 16 is 16 minus 1 times 0, so that just gives me 16. So my values for X and Y, X equals 48 divided by the determinant of the coefficients, which was negative 2. So that equals negative 24. And my Y value is equal to 16 divided by negative 2, which is negative 8. So my ordered pair is XY, negative 24, negative 8. Problem number 6. We have 9p equals 2q minus 6 and 3p minus q equals 12. The second equation is fine, so we'll just rewrite it over here. That's in standard form. The first one is not. So 9p, we need to bring the 2q over here by subtracting it from both sides, and that leaves the negative 6. So here are my x coefficients, here are my y coefficients, and here are my constants. So starting out with the matrix for the coefficients, I have 9, 3, negative 2, negative 1. Doing the multiplication, I get negative 9 minus a negative 6, which is negative 9 plus 6, so that's negative 3. The matrix for the x value is, since I'm looking for x, I don't put the 9 and the 3 down. I put the constants, negative 6 and 12. Leave the y column alone. Do the multiplication, negative 6 times negative 1 is 6, minus a negative 2 times 12 is negative 24. So I get 6 plus 24, which is 30. And then the matrix for the y value, since I'm looking for y, I leave the x column alone. I put the constants in, which were 6, negative 6, and 12 in the y column. This is the x, this is the y. Doing the multiplication, 9 times 12 is 108, minus negative 6 times 3 is negative 18. So that's 108 plus 18, which is 126. So x will equal 30 divided by negative 3, which is negative 10, and y will equal 126 divided by negative 3, which is negative 42. So my ordered pair is xy, negative 10, negative 42. Problem number 8, we have 5x minus 9y equals negative 3, and 4x minus 3y equals 6. This is in standard form. So the x coefficients are 5 and 4. The y coefficients are negative 9, negative 3, and the constants are negative 3 and 6. So my matrix for the constants would be 5, 4, negative 9, negative 3. Do the multiplication. 5 times negative 3 is negative 15, minus 4 times negative 9 is negative 36. So that's negative 15 plus 36, which gives me 21. The determinant for x would be, well, the matrix and then figure out the determinant, would be, since I'm looking for x, I put in the -3 and the 6 in the x column. I leave the y column alone, -9, -3. Do the multiplication, -3 times -3 is 9, minus a -9 times 6 is -54. So that's 9 plus 54, which is 60. And the determinant for y, the matrix is, leave the x value alone since I'm looking for y, and I put the constants, which were -3, 6 in the y column. Do the multiplication, 5 times 6 is 30, minus -3 times 4, which is -12. So that's 30 plus 12, which gives me 42. So my values for x and y. Take the y value for that determinant, divide it by the determinant for the coefficients, 21, and we get that x is 2. Y value is to take 42 and divide it by 20. Whoops, I'm sorry. That's and I can't add, I'm sorry, this goes back here and fix this. This is 63. So x is 63 divided by 21, which is 3. And y is 42 divided by 21, which is 2. So my ordered pair is x, y, so it'd be 3, 2. Problem number 10. Y equals x plus 2 and 2x plus y equals 11. The second one is in standard form. The first one is not. And remember, the x has to go first, so it's going to moving the x over here. It's -x plus y equals 2. Make sure your variables are the same order. So my coefficients are -1 and 2. Here it's 1 and 1. And the constants are 2 and 11. So the matrix for the determinant of the constant, of the coefficients would be -1, 2 for x, 1, 1 for y. Do the multiplication, -1 times 1 is -1, minus 2 times 1 minus 2 is -3. The determinant for x, since I'm looking for x, I put the constants in, 2, 11. Leave the y values alone, 1, 1. So multiplication, 2 times 1 is 2, minus 11 times 1, 11. That gives me -9. And then the determinant for y, since I'm not looking for x, leave the x alone, -1, 2. Replace the y column with 2, 11, the constants. Do the multiplication, -1 times 11 is -11, minus 2 times 2, which is 4, which gives me -15. So x equals -9 divided by -3, which gives me 3. And y equals -15 divided by -3, which gives me 5. So my ordered pair is 3, 5. Problem number 12. We have 3x minus 2y equals 1, and 4y equals 7 plus 3x. So get them in standard form. 3x minus 2y is in standard form. Bring the 3x over here, so I'd make it -3x plus 4y equals 7. Okay, the determinant for the coefficients would be 3, -3, -2, 4. 3 times 4 is 12, minus the 6 gives me 6. The determinant for the x value is, we don't want the 3 and the -3, so we put in the constants 1, 7. Leave the y column alone. Multiplication, 1 times 4 is 4. Minus -2 times 7, -14. So that's 4 plus 14, which is 18. And the determinant for y, since we're looking for y, we leave the x column alone, 3, -3. Put the constants in the y column, 1, 7. So 3 times 7 is 21, minus a -3. That's 21 plus 3. So that would be 24. Okay, to find x, we take d of x over d, which is 18 divided by 3, which is 6. And y equals d of y over d, which is 24 over 6, so y equals 4. And our ordered pair is x, y, so it'd be 6, 4. Okay, I made a mistake. Long morning. 18 divided by 6 is 3. So it should be 3, 4. And then the last problem is 14. And we have 2a minus 4b equals 6, and 7 plus a equals -3b. First one equation is in standard form. The second one, we need to slide the a to the b first, bring over the 3b, -3b, make it positive 3b, and then slide the 7 over here by subtracting it, so it's -7. So the determinant for the coefficients would be 2, 1 for the a column, and the b column would be -4, 3. So doing the multiplication, 2 times 3 is 6, minus -4 times 1, -4. So that's 6 plus 4, or 10. The determinant for x value is, since we're looking for the x, we put the 6 and -7 in that column, or the a column. And b stays the same, -4, 3. I'm just going to continue using x and y. 6 times 3 is 18, minus -7 times -4, minus 28. That gives us -10. And then the determinant for y value, since I'm looking for the y, I leave the x column or the a column alone. Put in the constants in the second column. So 2 times -7 is -14, minus 6 times 1, 6. That gives us a -20. So to find x, I take x equals the determinant value for d of x over d, so that's -10 over 10, which gives us -1. And the y value is the determinant of y over the determinant for the constants, so it'd be -20 over 10, which is -2. So a, b, or x, y would be -1, -2. That concludes the evens. Check the answers in the back for the odds, but make sure you do all the problems using determinants.